Hi, everybody. This is Mark Schuyler with Schuyler Tutoring. Today, systems of equations. This is the heart of algebra. They have another name as well, as so many things do. Sometimes they are called linear equations. So I will just write that up here. Linear equations. This is telling you something. It's telling you that these algebraic expressions are literally lines. They're actually lines. So, I think a lot of my students try to solve these and they try to solve for x and y and they're not even sure what they're doing, but you're actually finding the point of intersection of two lines. When you're solving for the xy, you put them together as a pair, an xy coordinate pair, and what you're actually getting is the xy point of intersection of the two lines. So great. Glad we got that out of the way. Let's take a look before we try to solve this rather hard one that I put up here. Let's actually try to solve an easier one. All right, so this is our new slide. Let's take a good look at it. You can see I've written a couple of identical systems of equations up here, but one of them we're going to purposely solve via the combination method, which also has another name. It's sometimes called, by some teachers, some students, it's called the elimination method, because that name really points out what we're trying to do is eliminate one of the variables, make one of the variables go bye-bye. The other method is known as the substitution method. It's important to know how to solve a system by both methods, not just one. If you only know one, there are some problems where you would probably just stick with your one method, that's the only method you know, and it would take a long time. But if you had known the other method, you could have made short work of the system. So, starting with the combination, what you want to do is draw a line underneath, and you want to either add them or subtract the two equations from each other. I used to have a teacher back in high school who said, stack them and add them. Stack them and add them. So you try to add first, as that's the easier operation than subtracting. And you're hoping that when you add these, one of the variables goes away. And so what do we get when we add x and x? We do get 2x. And the situation we were hoping for, the positive y and the negative y eliminate each other when we try to combine them through addition. So they're gone. And what do we have left? Well, we have to add the other side of the equal sign. We get 14. So we divide both sides by 2, of course. Whatever you do to one side, you have to do to the other, and you get 7. Well, that's the x value of the system. How do you get the y value? Not surprisingly, you come back to whichever equation you want. It doesn't matter which one, you'll get the same answer. And you drop in, you substitute in the value of x. So 7 plus y equals 10. So we subtract 7 from both sides. I think you can see y is 3. And as I said in my introductory slide, if you put the x value of 7 together with the y value of 3, you have an xy coordinate pair. You have a point. What point is it? It's the point where these two lines intersect on the xy coordinate plane. Now, these may not seem like lines, x plus y equals 10. That's called the standard form of a line. You're probably more used to seeing what we call the slope-intercept form of a line, which is the y equals mx plus b. But the standard form of a line is when you have, some number of x's, some number of y's, adding up to a known value. Let's call it b. Okay, so if we now look at the substitution method, we're going to get the same answer, but don't let that stop you from paying close attention to how this is done. First of all, the substitution method needs you to rewrite one of the equations where you get one of the variables all by itself. I think what I'm going to do is rewrite this bottom equation down here. I'm going to rewrite it so x is all by itself, which means I have to move the y to the other side. To do that, to move the y to the other side, I would have to add it, right? Because it's a negative y. So I have to add y, which means it better also be added over here. So I'm going to rewrite the bottom equation as x equals 4 plus y. And I'll put a little pair of parentheses around that to make it clear. Now that we've rewritten the equation, so it's just in terms of one of the variables, in terms of x, we can drop in what we know x is into the other equation. So we know that x is the same thing as 4 plus y. So if I drop it in there, it's going to look like this, 4 plus y. Okay, I'll put parentheses around it, plus the y that's here. Do you see that y that's up there? And it equals 10. So we have 4 plus 2 y's equal 10. Subtract 4 from both sides. 2y equals 6, and a single y would be equal to 3. Well, you could see, of course, that's the same thing that we got for the y value over there. Once we know one of the variables, it's super easy to get the other. Just go back to the equation, substitute it in, and you'll find that x is 7. You put the 7, 3 together. Remember, x, y, x comes first, and you have that point of intersection of the two lines. Now, you might be thinking, well, what do I do if I have a really hard system where none of the x's and none of the y's are just a single x or a single y, where there's, well, like 3 x's and 2 y's, or 7 x's and 8 y's? Well, that is a problem. It's probably not a good time to use the substitution method, since we know we want one of the variables to be just a single x or a single y, so we can rewrite the equation easily and substitute it into the other equation. So let's go back and look at the really hard slide that I had before. Okay, so here we are with our 2 x's and 3 y's, or our 3 x's and 2 y's. So with this kind of a problem, substitution method is off the table. So we're going to have to try to use the combination method. But as I draw a line underneath this in preparation of either adding or subtracting, I can see that there's a problem with adding. If I add, I'm going to have 5 x's and 5 y's. Do any of the x's or y's go away? No, they don't. So let me try subtracting. That's the next thing to try. But if I subtract, I'm going to have a negative x and a positive y. They haven't gone away. They haven't disappeared where I have 0 x's or 0 y's. So that's not working either. So you can see this one is relatively challenging. So what you do is you have to use a little bit of algebra, some simple algebra, where you're going to multiply both these equations by different numbers. And the idea is you're going to match up the x's or the y's by doing it that way. So for example, let's say I multiply this top equation by negative 3, and I multiply the bottom equation by positive 2. Now you have to take a second and distribute that negative 3 out to every term of the problem, even on the other side of the equal sign. Don't forget that. And so real neatly over here, I'm going to rewrite the equation. It becomes negative 6x minus 9y equals negative 39. And then I'm going to also distribute the 2 out to everything here, even on the other side. And write out, oh, look, I have a positive 6x. That was the intention, right? And I have a positive 4y. And on the other side of the equal sign, I have a positive 24. Let's draw the line underneath, getting ready to add. When I add these, the negative 6 and the positive 6 cancel. That's what we wanted, the x's to go away. But when I add the 4y to the negative 9y, I end up with negative 5y. And I end up with negative 15 on this side. But if I divide both sides by negative 5, I'll have y is positive 3. Look at that. That's nice. We know that from here on out, it's pretty simple. Let me go back to one of the original equations. I'll rewrite it here. It was 2x plus 3y. But for the y right here, I'm going to drop in the 3. I have down here at the bottom that y is 3. So I'm substituting it in, set it equal to 13. Simplify, that would be 2x plus 9 equals 13. Okay, and then if I take that 9 and I subtract it, I'm going to have 2x is equal to 4, and so a single x is equal to 2. Don't forget to put the values of x and y together. You could write them as a coordinate pair. 2, 3. This is the point of intersection of a pretty hard system of equations where you had to multiply both of the equations by different numbers so that you could match up the x's and eliminate them by combining them through addition. So I don't want to make the video too long. Just consider this an introduction to systems of equations, but they are the heart of algebra. If you know how to solve a system via both methods that I've gone over here, you have a rock-solid foundation in the algebra that's tested on the ACT and the SAT. So, thanks for watching. Good luck.